영어로 해야 되죠, 이거? Hi. So the questions that I solved were problem number 24 and 35. Okay, so the first question was that I had to find the millionth of lexicographic permutation, and to give a brief summary of what lexicographic permutation is, that it's that the numbers or permutations are listed numerically or alphabetically in lexicographic order, like this. So my task was to find the lexicographic permutation of the digits from 0 to 9. So it's a pseudocode, which is kind of like the algorithm that I came up with during the process. And the first step was that I had to create a list using permutations, and the reason I chose to use permutations was because, unlike the other problems, this one required me to do it, and it was also rather a rapid reach to the solution instead of using the tables arranged like we always do. And the next step was to construct a number using from digits, since after using the permutations it was divided like when you use integer digits. And lastly, since the question was asking for the millionth lexicographic permutation, I used double brackets, which identifies the millionth of the list, and therefore I indexed the millionth of lexicographic permutation, and that gave the solution to this problem. And that's basically it. So here was that I created this to create the list of permutations, and this meant that I constructed integers from this list, and this meant the millionth of the entire list here, and the final answer was, I don't know how to read that. Yeah, that. So that's that, and this was the final solution for problem 24. And finally, for problem 35, the question was that how many circular primes are in below 1 million? And basically, circular primes are rotation of digits. For example, if the number or the integer is 197, then the circular primes of 197 would be 971 and 719. However, it wouldn't be like 791, because that would be that would not be a prime. So these are all primes and they're all rotated. And the task here was to come up with circular primes below 1 million. So the first step I took was, so I solved for the prime numbers just below 1 million, and as I found out, the 78,490th prime number was 9, and this was just below 1 million because after that was over 1 million, so yeah, that's it. And next I broke up the integers using integer digits in order to rotate the number afterwards using rotate left function. And rotate left function allowed me to rotate the digits. And then afterwards, I constructed integers using from digits, and I used map command to apply it to the entire list. And so since the problem was asking for circular primes, the next step would obviously have to be checking the integers that I constructed were primes or not. So then I used select command and also prime q command, which allowed me to check if the numbers were primes or not. And afterwards, when I actually came up with the list, or actually got the list, I found that there were numbers that were being repeated. So then I used union command in order to make sure that there were no overlapping numbers. And this step kind of repeated over and over again until I finally got to where I rotated the number 6 times, since the maximum number was 6 digits. And at the end, when I finally got to the point where I rotated 6 times, I use select command and also prime key command to check the numbers, or check the prime numbers of the list. And at last I used the length command to find out how many circular primes were there just below 1 million, and the answer was 55. So these are the screenshots of steps I took. So again, the first step was selecting prime numbers below 1 million, and then I broke apart the integers using integer digits. And then I rotated the integers using rotate left. And the next step was to construct integers using sum digit. And the next was again prime numbers using select command and prime q command. And also I used union again because make sure there were no overlapping prime numbers. And it was just the same over and over again. Until like, oh, that. Okay. So after when I selected the prime numbers, after rotating 6 times, and I got the length, it was 55. Ta-da! Thank you.
Question? Any question?
Any questions? No questions.
몇 번 로테이트 했어요? 35 문제에서?
Yep, 6 times.
6 times?
Yeah.